Hi, and welcome to the Cis-Lunar Space Neutrino Laboratory, better known as the CLuS'N Lab, or simply CLuS'N. CLuS'N is an autonomous robotic spacecraft being built for the purpose of studying neutrinos. A little background on neutrinos. They are very fast. Cosmic speed limit. That's very fast. The CLuS'N spacecraft is being built with 16 galactic propulsion engines, an optical infrared microtelescope, including a galactic cosmic rays sensor that will observe X-rays and gamma rays. Why did we choose the lunar orbit for the mission? Well, the moon has a very weak magnetic field that will allow us to do precise measurements with very minimal interference. Neutrinos are still being studied in order to determine their relationship with gravitational wave events. The mission will be observing cosmic rays in order to determine whether they are being generated from binary systems of black holes or massive stars or supernovas. We do know that gravitational waves have been created by those phenomena, but where and when and how are the questions that still need to be answered. What we are trying to do here, we are understanding the quantum state of space-time. Now, what does space-time have to do with neutrinos? Now, the formula that we see in here of the neutrinos, C prime represents the speed of the neutrinos, and nu represents the quantum state of space-time. Now, the moon is known to be composed of neon, helium, and hydrogen molecules. That's from the Apollo 17 mission. We also know that tritium is produced when GCRs collide with hydrogen molecules, and that tritium half-life beta decay generates helium-3. The CLuS'N spacecraft will observe those three molecules for the purpose of capturing in real time the birth of tritium, the resulting elements from the interaction of GCRs with neon and helium. It will process the resulting particles and engage the differential analysis equation to the observed rays. What are we trying to accomplish in doing that? Decrypting messages that are coming from outer space. Now, the numbers that are next to are in parentheses next to those three elements are in joules. How did we calculate those numbers? In using the atomic mass of this element times c squared, speed of light squared. Now, why are we doing that with the neutrinos? By having a similarity as far as speed with light, current science and technology are using the speed of light basically to estimate the speed of any object that is in the universe, including spacecraft. Now, in order to understand the quantum state of space-time, we need to use another variable that is very similar to the speed of light, which is the neutrinos. Knowing that the neutrinos travel at the speed of light, in using that equation, we're aiming at producing the same effect that light produces when it travels. So if you are able to determine values that are created from the interaction of GCRs with elements that are found on the lunar atmosphere, we can separate the neutrinos, and we can also evaluate which source are they from. This is a big leap into understanding the quantum state of space-time. If we can accelerate matter in using fusion of atoms, then we should be able to accelerate matter at a bigger scale, such as accelerating spacecraft in designing propulsion engines, propulsion systems that are based on other factors, other laws of physics, such as the CLuS Neutrino formula here. Intergalactic traveling is very possible, in theory, of course, but this work here is coming to a conclusion. And at the end of the work, then we'll understand how to maneuver particles in order to accelerate them at the speed of the neutrinos, not the speed of light, but the speed of the neutrinos. This is a very interesting project that we are undertaking, and really we can't wait to discover what are after. We can't wait to discover what these question marks are. And the CLuS'N mission will enable the development of what we are trying to accomplish, which are galactic propulsion systems to further enable space exploration. during our time. What we're seeing here is the bottom of the spacecraft, the size of the spacecraft, the weight of the spacecraft, as well as the trajectory that we will need to accomplish in order to stay in orbit around the moon. Now the lunar insertion is going to be accomplished at around 850 meters per second in order to yield a near circular orbit at around 100 kilometers above the lunar surface, with an inclination range of 30 degrees to 150 degrees. As far as communication system-wise is concerned, we are planning to using the Deep Space Optical Communication System provided by NASA.